Today we will explore the Integra 8S digital audio matrix by WorkPro. The first thing to do is open its software, Integra S. Select that we will be working with the Integra 8S. We go to the upper right corner to the device list and it will display all the connected devices. In this case, we have only the Integra 8S, so we connect it. Now we're inside the matrix. On one hand, it's a very simple and visual interface. As you can see, here we see the gain control. We have the phantom power indicator, phase inversion indicator, expander module, compressor module, auto gain module, equalization module, and anti-feedback module. Finally, we have the channel volume fader. We have the option to mute and unmute the channel. Control the volume level by sliding or numerically. We can also link the channels so that these 8 input channels become 4 stereo channels, which are controllable among themselves. And we could also easily rename each channel by double-clicking on its name. In this case, since we are going to have 2 line inputs and 1 microphone input, we'll call it line 1L, as we'll assign a line signal to the input. Input 2 will be called line 2R, and input 3 will be called mic notice. To change the different input parameters for the channels, we select the channel we are going to use. We go to Input in the upper menu bar. Here we have the interface where we can see, on one hand, the analog input and a signal generator. We already have an audio source connected to the matrix. In this case, we can see that the channel 1 input is already peaking. We select sensitivity for channel 2, and there we have it. In the case of the microphone, let's make sure we have a signal. There it is. Since it's a dynamic microphone, we don't need to connect the phantom power nor change the phase. This is the sine wave generator. When selected on channel 1, we can see that the signal is a stable sine wave at 1000 Hz at minus 48 dBs. We can expand it as needed. This would be great for soundproofing a room. We can also generate white noise and pink noise. Let's go back to the analog input, which is what we're interested in at this moment. If we go to the next module, as we can see, the selected module always highlights in red. Here we have the expander module. First of all, we would activate it by clicking on On. We can vary the parameters, such as the threshold, which we could adjust by sliding the red line button. We can also adjust the ratio, attack, and release in milliseconds. We can also make numerical adjustments, allowing us to fine-tune the signal. Let's go to the equalizer. We activate it. We can vary the different bands. We can have parametric equalization for lows, for highs, high pass, and low pass, whichever interests us at any given moment. And just like in previous models, we can modify the signal by directly dragging the points on the line. And adjust the bandwidth with a Q factor and octave control. Depending on how we want to fine-tune this signal, we can do it manually by dragging, or we can do it by entering the values. Next, we have the feedback module. We activate it. In this case, it detects an input at 16 kHz. We see that it's dynamically activated. If we select it to be fixed or manual, it wouldn't operate automatically and would solely be working to help us regulate this signal. Now let's look at the AUTOMIXER module. First of all, we connect it. For the moment, it wouldn't be working because we are not sending the channel signals. We would select the two line signals and the microphone, and we can establish which of our inputs takes priority over the others. In this case, we prioritize the microphone, and we see that when speaking through it, the other signals are attenuated. We will also have a gain in dB in the upper right corner, slope, and a response time in milliseconds, and of course, a general mute for this model. If we go to the AAC acoustic echo cancellation mode, we activate it. We have different modes of operation: a soft mode, a moderate mode, and an aggressive mode. We can specify on which local inputs and which remote inputs we want this to act. Including the USB player. The ANA's automatic noise suppression mode operates similarly to the AAC mode. We activate it and see that in the drop-down level it gives us the options to act on 6, 12, 18, 44 and 30 dBs. We select the channels on which we want it to act, including the AUTOMIXER, the USB player, and the AAC module. If we go to home, we'll see that the AUTOMIXER is connected, that the acoustic echo cancellation mode is connected, and that the automatic noise suppression mode is connected. And on the channel we've working on, we see the modifications made to the signal. Now let's look at the matrix. It's very simple and intuitive. If, for example, we want line channel 1 and line channel 2 to go output 1, we press at their intersection. We can plug and unplug as we wish to route the signal. This output, named as 1 for example, can be renamed as we want. In this case, room 1, output 2 would be room 2. We will also include the announcement microphone in this room 1 output and could also switch in this matrix its various functionalities, like the USB player, or have the AUTOMIXER send us that audio mix it is producing to different outputs. In this case, we'll send it to 2 and 3. Let's look at the configuration on the output channels. We go to the upper bar and select Outputs. We see that we have the channel named Room 1, Room 2. It operates very similarly to the input channels. We have filters, equalizations, delay, and a limiter. Let's see on the output channel Out1 that we've renamed it as Room 1. We go to the upper bar to Outputs. In this channel we will see how to apply the different filters. First, we activate it. On one side we have low-pass filters and on the other we have high-pass filters. We can vary the operating frequency, the gain, and the different types available: Bezel, Butterworth, length with relay. We can adjust the slope in steps of 6 dB per octave from 6 to 48. The same applies to high-pass filters. If we now went to Home, we will see the shape of the filter that is in operation. We go back to Outputs. The channel's equalization is exactly the same as in the inputs. It's adjustable parametrically with low shelf, high shelf, low pass, and high pass filters. Operating the same way, in this case, we see that the Q factor is very wide. We can narrow it depending on the equalization needed. We have an adjustment for the signal's delay in milliseconds, in meters and in feet. If we change these values numerically, the rest change as well. The same happens if we adjust it by sliding the bar. We have an output limiter. We will activate it with threshold and release adjustments in milliseconds. Additionally, in the output settings, we have a mute and a phase shift, which would act directly on the channel. Now let's go to the meters module, where we'll see 3 input signals directed to one output. We will see all the assigned inputs and outputs peaking. We have the possibility of obtaining custom commands in a very simple way. We go to the Help mode, Command Capture. Here we would capture the command, stating that the programmable GPIOs, which we will see shortly, act in a specific way. Thus, we can establish that in the line 1L channel, this command will mute the channel from an external GPIO panel. If we now go back to Home mode, here we will see the changes we've made in the different equalizations. Let's look at different options for the device settings or adjustments. With device settings, we can change the name of the device, especially if we have different matrices on the same network and we want to name each one according to the zones they serve. We can set the IP, the gateway, the network mask, the MAC address, and have it start with one of the different presets that it allows us to save from 1 to 16 or the last preset that we have used. In this other part, we see the modes of RS232 and RS185 control ports that the matrix has. We also have programmable GPIOs, 4 inputs or 4 outputs that we can select. This means that we can connect different devices and assign them a multitude of functions through these GPIO ports. In the case of, for example, this GPIO port 1, we're going to set it as an input. We want it to be a mute. This is either active or off from the start. We can select the different trigger modes, and it can act on inputs, outputs, or the system's master. The output GPIOs would work in exactly the same way. We would tell it to act on the outputs. In this case, it gives us fewer options. We could say it's a level option, that the output starts at a lower high level, whether it starts active or not active, and on which output we want it to act, for example, at channel 1 from 0 to minus 72 dBs. We would save, naming it as GPIO1 save, and it would be set. A module that will make it easier for us to group different zones under the same control is the input and output grouping module. We could establish, for example, that inputs 1 and 2 go together in one block, 3 and 4 in another, 5, 6 and 7 in another block, and 8 in another, making up to 4 different blocks. And the outputs would work in exactly the same way. Output 1 on one side in group 1, outputs 2, 3 and 4 to group 2, outputs 5 and 6 to group 3, and outputs 7 and 8 to group 4. Now we will see that in this case, without the channels being linked, they would act simultaneously. What was once an entirely gray pilot has now changed color. And those in the same group have the same color. The same applies to the outputs. The names of the presets with which we start our matrix can also be changed. For example, we can call this preset 1. Normal day with low public attendance, and preset 2, high attendance. As we will have more people, we will need more power in the PA system. We save it. And if we go to the drop-down, we see the different renamed presets. With these 16 different presets, we multiply the functionality of the matrix, allowing us to have these 16 possible pre-recorded scenarios and not have to make substantial changes day to day. We are going to enter the panel setting option. This is a very interesting mode as it allows us to connect wall control devices via PoE LAN to our matrix in a very intuitive way. Here we have created a WC3U control panel in the same IP range as our matrix. We double-click on it and here we have its IP. We can rename it, in this case as kitchen control, and confirm it's in the same IP range. If we go to edit, we can see that it can act on all the channels that the matrix has, we could change the function name. It would indicate a minimum and a maximum of dB that we could set numerically, and if we want it to act in steps from 0.5 dB to 10 dB. We can also make it function as a button for the different channels, work as a color to the different presets we have in the matrix, function from a command capture, or even work as a selection matrix. Now we have this control panel connected to a desktop device, and without touching the cursor over the channels, we turn the physical knob of the control panel and externally adjust the volume. We enter the user interface. This is an interface for creating a control surface on a tablet, phone, or even a computer connected to the same network to remotely access the different parameters according to the template we are going to create. First of all, we establish a template. We can see different pre-made templates for Android or iOS, tablet or phone, or we can go to the template of the device we are going to use. In this case, we have a tablet connected to our network. It's an Android tablet with a template resolution of 1200 by 2000, a density of 1.5, and its assigned IP address. We have previously installed the APK that we provide to all our installers on this tablet, and we are going to rotate the template since we want this format for our design. First, we insert an image. As simple as clicking on the image icon and dragging, we go to the browser and select the image file we want to use. Next, we insert a channel. In this case, it's an input channel. We can adjust the width, height and corner radius, and in this case, it's channel 1. We set the width, height, corner radius, and always have to set the IP address of the device it will act on. We copy this IP because we'll use it a couple of times. We select here that it's an input channel and it's channel number 1. We'll add some more. Indicating its input channel number 2. We add third, which is input channel number 3. We will add an output channel exactly the same as with the input channels, indicating its output channel 1 in this case. We can assign a small matrix. We'll assign a 3 by 3 matrix that will act on our machine. And we could even customize the levels of other channels without the control appearing. In this case, we will assign input 5. And in this other case, we could have a potentiometer for input 6. We could add input-output level indicators for any other channel. We can also add as many pages as we need, with different configuration options. this case, and as an example, we will also have control of channel 1. We would save this project. And now we would synchronize it with our tablet. We go to the Synchronize option. It will search for the devices we have on our network. We select it, click on Synchronize, a percentile appears with the file transfers. The same percentage will now appear on the tablet. To carry out this step, remember to have the tablet's APK open. As we can see, the upload have just finished, and now we will have these controls options on our tablet. Now we will exit this editing mode, and from the tablet we would be acting on the inputs and outputs. If we go to the matrix, we see that we can establish different scenarios. With this application, from any point in our installation reached by the Wi-Fi network, we would have control of our matrix, providing us great freedom for in situ adjustments and not limiting us to do it locally. One of the options we have for informational purposes in Help About indicates the version of the software we have installed. To play audio such as background music from our matrix and distribute it to different zones, we can do it with its built-in player. We would just configure the sound card we are going to use, in this case the Creton USB sound card, which is the matrix on. We go to the player, we add, we open these test files we have, we play, and if we go to the matrix and disconnect the inputs we have, we see that we now have nothing on the output. We root the player, activate it on output 1 and see that it's now active. And for the recording module, we will simply go to the settings, select from the different computer input devices which one we want to record, in this case, what comes in through the Creton card of the matrix. We want to record this as a stereo, the folder where we want it to record, and by pressing the recording icon, we would be recording. And with this, we have now finished this short video tutorial where we have seen all the possible options and configurations of our Integra 8S Digital Audio Matrix from Work Pro. We hope it has been to your liking, and we look forward to seeing you again soon.